Hello students, today we are going to see JEE Advanced 2024 Physics Paper 1 solution. So let's start. So this is the question number 1 they have given. So in the question number 1 they are basically telling that this term basically e to the power alpha, epsilon naught to the power beta and h to the power gamma and c to the power delta. This full term is a dimensionless quantity and E is charge, epsilon naught is your permittivity of free space, h is your Planck constant, c is your speed of light. So and they are asking you to find out alpha, beta, gamma, delta, right? So here if you see this is e to the power alpha, epsilon naught to the power beta and h to the power gamma, c to the power delta. This full term is dimensionless, that is m0, l0, t0, i0. I0 I am taking because here charge is sitting, right? So that's why I am taking. So charge dimensional formula will be what? Will be Ti, right? So T to the power alpha, I to the power alpha I can write. So epsilon naught, you can find out the dimension for epsilon naught. This will be basically you will say that q square divided by f r square dimension, right? So this will be T I T square I square divided by f will be m1, l1 and r2 will be l3, t to the power minus 2. So this will be m minus 1, l minus 3, t4, i2. Okay, so epsilon naught to the power beta obviously you will get m to the power minus beta, l to the power minus 3 beta, t to the power 4 beta and I to the power 2 beta. Clear? And h to the power gamma, if you find out E equal to h nu, you know. So h will be E into t dimension, right? H dimension. So this will be m1, l2, t minus 1. So h to the power gamma obviously m to the power gamma, l to the power 2 gamma, t to the power minus gamma. And c to the power delta, c is the speed of light. So l to the power delta, t to the power minus delta, t to the power minus delta. Clear? This whole term m0, l0, t0, i0. Okay, so here you see first in LHS and RHS, see the power of the mass. So if you see the power of mass, this will be minus beta plus gamma is equal to 0, right? So what you will get? Beta equal to gamma. Now see for length, that will be minus 3 beta plus 2 gamma and here plus delta is equal to 0 RHS, right? Power. So here gamma, beta equal to gamma, right? If you beta equal to gamma, what you will see that here will be minus beta plus delta. So we will get beta equal to delta, right? Because I put beta equal to gamma. So this will be formed. So from these two, what you will get? You will get that beta equal to gamma equal to delta. Now alpha is left. Alpha I have to find out. Let's see the power of this current. So it will be alpha, here plus 2 beta. There is no current, that side it will be 0. So what you will get here? Alpha equal to minus of 2 beta, right? So alpha, beta, gamma, if you write down now, alpha equal to minus 2 beta I can write, and your beta equal to beta, and gamma and delta also beta, right? So I can write beta, right? Beta. So I can write. Okay, so this will be basically minus 2, 1, 1, 1. Now if I see here, they have given the n is a non-zero integer. So they have given the answer in the form of n, right? So we have to multiply n. So if you multiply n, this will be minus 2n, n. So no option will be matching, right? But if you multiply a minus n, because n is a non-zero integer, so n can be positive as well as negative, right? So let's take n equal to negative. If you take n equal to negative, this will be basically 2n minus n will form. So option A will match here, correct? Okay. Now go for the second question. So in this question basically you have to find out the b dot dl. So let's say I am taking this is along x direction and this is your along y direction, and this is that center here, right? And the current is positive z direction along this direction, okay, outward the board. And from here you have to integrate minus root 3a 0 to, you have to integrate up to a 0. Clear? So to do this one b dot dl, obviously I have to take a small length element here, that is dx, and that distance here to here is x, right? That thing I have to take. Clear? This distance is x. Now let's find out the magnetic field due to this wire at this point, right? At this point let's find out the magnetic field at this point, right? At dx, very small length element, right? So you will tell that let's say this distance is r, and obviously the magnetic field due to this wire will be perpendicular to this one. That should be like this. This should be your magnetic field direction, right, at this point. And this r and magnetic field should be perpendicular here. So I can say that this should be perpendicular. And let's say I am taking this angle is theta, obviously this angle will be 90 minus theta. So you will tell that this angle will be again theta. Clear? This thing we got. And this distance obviously you can find out, you will tell that this distance is your a, because y is a, right? Y is not going to change, y is a. Now I have to find out b dot dl. First find out b. So obviously b will come as, b magnitude will come as mu naught I divided by 2 pi r, right? This will be your magnetic field magnitude at this point, right? R is the distance from here to here. Okay, so b dot dl, if you write here, I am writing b dot dl integration, dl is along this direction, right? Your dx, you can say that, and b is along this direction. So obviously this is the direction, and you can say that this angle will be your pi minus theta, right? Because this is theta, this will be pi minus theta. Because b direction along this direction, x direction along this, or dl direction along this direction, this will be angle between these two for dot product. So for this one it will be coming as mu naught I divided by 2 pi r, and dl will be your dx and cos of pi minus theta, right? That outside angle, right? Like we do dot product, right? So here it will be mu naught is constant, I is constant, 2 pi is constant, you can take it out, right? So this will be dx by r, cos pi minus theta will be obviously minus of cos theta, right? So this will be minus of cos theta. Clear? Integration is there. So this will be mu naught minus mu naught I divided by 2 pi integration of cos theta value. What I can write? Cos theta is basically, if you see, cos theta is actually a divided by r. R is basically what? A square plus x square root over, right? A square plus x square root over. So in place of cos theta I am writing a divided by a square plus x square, and r value also a square plus x square root over, right? So this will directly I am writing dx divided by a square plus x square, and there is a is there, I am taking that a outside. Clear? And x is varying from where to where? Minus root 3a to a. So write down dx is, this will be minus root 3a to a. Clear? Now see here, this will be minus mu naught I divided by 2 pi. This integration, this is standard integration, right? So this will be 1 by a, here a is there previously, 1 by a tan inverse of x by a, right? This is standard integration formula, dx by a square plus x square, right? So this will be minus root 3a to a. So a get cancel out here, this will be minus mu naught I divided by 2 pi tan inverse x by a. So you put a here, this will be tan inverse of 1 minus of tan inverse of minus root 3, right? So this will be minus mu naught I divided by 2 pi tan inverse 1 is pi by 4 minus tan inverse of minus theta is minus tan inverse of theta, right? So you take it in minus, so it will be obviously plus, and tan inverse of root 3 is basically, you know, that is your 60 degree, right? Or you can say that is your pi by 3. Okay, so obviously this will be minus mu naught I divided by 2 pi, and this will be 12, 3 plus 4, right? 7 pi. So you multiply here, it will be pi get cancel out, it will be 24 minus 7 mu naught I divided by 24. So this should be your answer, but they are asking that magnitude. So if they are asking magnitude, you just take the mod here. Mod will be obviously b dot dl, integral mod will be obviously 7 mu naught I by 24. So this way you can calculate. So A option is your correct option. Let's go to the next question. Two beads each with charge q and mass m are on a horizontal frictionless non-conducting circular hoop of radius r. One of the bead is glued to the hoop at some point while the other one performs. So this type of question we have seen, right? So we can solve this type of question. So what we will do? Basically this is a circular hoop they are telling, right? And here one bead is there, right? And this one you can say that this is the center of that circular hoop, and another bead is there. It is in equilibrium. All these things are in your horizontal table, right? So here the mass is m, charge is q. This one also mass is m, charge is q, right? So basically if you displace little bit, let's say you slightly displace here, right? Here you displace slightly. So this will be very slight, small displacement, but here I am showing it will be big to do the calculation, right? So it will be, let's say, here. Clear? But it will be very small. You can assume that this is a straight line type of thing. Clear? This will be very small, this displacement, right? Because they are asking about small oscillation. So you can say that this length is 2r, and at this point it is going to be disturbed from the equilibrium position or mean position. This is your mean position. So this is charge q is there, here also charge q is there. So you will say that there will be a repulsion force, right? Coulombic repulsion, and that will be F equal to, that will be k q square divided by, let's say this length is L I am taking, this full length I am taking L, this will be L square, right? And you know that if the bead is there, there will be a normal force by the hoop through the center, right? This will be a normal force. So basically this force will be divided into two components, one component along the normal and one component along the tangent. This tangential force is basically working as your restoring force, right? That try to bring that bead to this position, mean position, right? So let's take this angle is theta, and you will tell that this angle also theta and this angle also theta. So this will be basically f of cos theta, and this will be basically f of sin of theta, right? So f of sin theta is your restoring force. So restoring force, I can say that, so I can say that restoring force is equal to f sin of theta, right? So f value you know that is k q square divided by L square sin of theta. Now L value you can calculate. This is your r, this is also r, and this length you can find out, right, by vector calculation. This is r, this is r. Obviously this will come as, this length will come as, you can say that this will be r square plus 2r square cos of, this will be pi minus 2 theta, right? You can say that this will be pi minus 2 theta cos of this angle right here. This will be your theta, this will be your pi minus 2 theta. If this is pi minus 2 theta, obviously this will be coming as 2 theta. This angle you have to take cos of 2 theta, right? So this root over you can find out. So it will be obviously you can take common here 2r square. So this will be root 2r, that will be 1 plus cos 2 theta root over, right? So this will be root 2r 1 plus cos 2a 2 cos square a. So this will be root 2 cos theta. So this will be coming as 2r cos of theta. So this length is L equal to basically 2r cos of theta, right? So you can write down L value here. So it will be kq square divided by 2r cos of theta whole square into sine of theta. Now theta is very small here. Theta is very small means sine theta is replaced as here theta and cos theta is replaced as 1, right? So this will be coming as kq square divided by 4r square into theta. Now theta value you have to find out. Okay, so restoring force value will be this much. If you find out the theta value, 2 theta, if you see here 2 theta will be, because I am telling this length will be very small, this will be behave like a straight line. That means this is very small, right? So this length I am taking as x, this length I am taking as x here, because it will be very small. I am showing it is very big, it is arc type forming, but it will be somewhere here maybe. So it will forming like a very straight line, right? So I am taking this one as x. So 2 theta value you can say that 2 theta equal to x by r. So theta value x by 2r, right? So this will be basically kq square divided by 4r square. Theta is x by 2r. So you can find out this will be obviously kq square divided by 8rq into x. This will be a restoring force, right? Now you can find out the acceleration here. So acceleration will be for this straight force. So acceleration will be here, I am finding acceleration will be here kq square divided by 8rq by mass, right? Mass of the bead. This will come and there will be x. So you know that for SHM or small oscillation you can say this will be a equal to minus omega square x, right? So you find out this will be your omega square, right? So omega equal to kq square, sorry, omega square equal to kq square divided by 8rqm. So see which one is given. Oh, they have given k to 1 by 4 pi epsilon naught, no? So you can write q square divided by 1 by 4 pi epsilon naught. If you 8 into 4 will be 32. 32 pi epsilon naught rq into m, right? 32 pi epsilon naught rq into m. Which one it is matching? So the option number B will be correct, right? So this will be 816. Yeah, option number B will be correct. Clear? Now go for the next question. So this is the force they have given. So force is given as F equal to minus 20x plus 10. If I want to find out the mean position, so mean position will be coming as your, the force will be 0 minus 20x plus 10. So x will be 1 by 2, that is 0.5 meter, right? So this will be your mean position here. This will be your mean position or equilibrium position. Clear? From this force you directly can say. Now they are telling the value of x in meter, right? So at that thing we will tell a meter. So at t equal to 0 it is at rest. So t equal to 0 it is at rest and position x equal to 1. So what I am doing here, this is I am taking. So this is t equal to 0, let's say. Here v equal to 0 and x equal to basically 1. Got it? So v equal to 0 means what? This is the extreme position, right? So you can say that this is extreme position. So this is your extreme position, right? Now mean position also you got. This is your mean position. Mean position is your 0.5 meter. Now see what they are asking. The position and momentum of the block t equal to pi by 4. You can find out the time from here, right? Because f equal to minus 20x plus 10. So you will tell that omega, that is frequency, angular frequency, will be k by m root over. So k is basically what? 20, right? Divided by mass, they have given 5 kg. So you can put 5 root over. So this will be 2, 4, then it will be 2. So omega you will get 2. So if omega equal to 2, time will be 2 pi by omega. So that will be pi. So time period of this SHM will be pi. So if time period is pi, obviously from extreme position to mean position, how much time it will take? It will take pi by 4, right? That is t by 4 second. So pi by 4 second it will take to extreme to mean position. So they are asking that the position and momentum of the block at t equal to pi by 4 second. So t equal to pi by 4, the position will be x equal to 0.5 meter. Clear? Now momentum you have to find out. So momentum, you know that at mean position the speed will be a omega and it is moving along this direction from this extreme position, that means velocity will be minus a omega, right? So you can put amplitude into omega. Amplitude will be how much? This is 1, this is 0.5, so this will be minus 0.5 amplitude meter. 0.5 will be your amplitude into omega equal to 2. So this will be minus 1 meter per second. Here is your velocity. So momentum will be basically P equal to your m into v, right? So mass is 5, this will be minus 1, that will be minus 5 kg meter per second, right? This will become your momentum. So they are asking the position and momentum. So position will be your x equal to 0.5 and momentum will be minus 5. So just check which one, 0.5 minus 5. So option C will be your correct, right? Okay. Okay. Now go for question number 5. A particle of mass m is moving in a circular orbit under the influence of the central force F r equal to minus kr. So what they have given here, I am writing. So Fr they have given, force they have given minus kr, right? Corresponding the potential energy also they have given, Vr they have given, that is k r square by 2, that is the potential energy they have given, where k is positive force constant, r is the radial distance from the origin according to the Bohr's quantization. So they have given the angular momentum also. So L equal to nh cross, and you know that that is same as your mvr, right? That thing is there. So now this object is moving in a circular path. So if it is moving in circular path, it has some speed and it has mass. You can say that mv square by r equal to kr. So first thing you got here, mv square by r equal to your kr, right? Your kr. So v square equal to k by m into r square. This relation you got, first thing. So now see here, they have given v square, r square, L by mr square, energy, all these things you have to find out. Let's find out the v square first, because we got v square here. So v square equal to k by m. R square you can see all these things they have given nh cut form, right? So r square you can put from here. So r square will be basically n square h cut square divided by m square v square. So r square I can write from this equation, n square h cut square divided by m square v square. This can write. So v square multiplied with this will be v to the power 4. This will be, sorry, this should be v to the power 4. 1 minute. Okay. Okay, so this is v to the power 4 and this will be your, you will tell that k divided by mq n square h cut square, right? So v square will be obviously, so v square obviously k by mq root over, this will be nh cross, right? So you see here k by mq nh cross. So the option B is correct. Now let's check option number C. So option number C basically telling you L square, C I am taking L divided by mr square. So L you know that is mvr divided by mr square. This is basically V by R. So V by R, you will see here V by R equal to K by M root over, right? So this will be K by M root over. So this is also true, C also true. Let's check A option. So for A option, this is R square they are asking. R square we have seen, right? V square into M by K. Clear? So this will be V square. So V square I can write, this will be K by MQ root over NH cross V square into M by K. So I have to write M by K. This will be your R square. So you see here M, 1M get cancel out, K will come. So this will be 1 by MK, right? 1 by MK root over NH cross is equal to R square. So check here, yeah, this will also correct. Now last option is there D. So if I check the D, energy they are asking, energy basically this will be kinetic energy half mv square plus potential energy will be, you see here how much, what a k r square by 2, right? So k r square can be written as mv square, right? You see here k r square equal to mv square. So I am writing half mv square plus half mv square. So this is coming as mv square. So if this is coming as mv square, v square value it is known to me. I can put here m into k by mq root over into nh cross. Clear? So this will be n h cross, m, 1m will come out, it will cancel out, k by m root over. Clear? So they have given nh cross by 2. So this is incorrect, right? So option number A, B, C are correct here. Clear? Okay. Now this question, so there is two strings there. This is length L and mass per unit length here given mu. Okay, so here I am doing, this is mu, right? And this side it is 4 mu. And the length is 2L here. They have given, okay? And they have given the frequency 1 by 2L T by mu root over, right? One frequency they have defined. Now which of the following is correct? With a node at O, the minimum frequency of vibration or composite string is mu naught. So if you see here, they are telling O at node, right? So I am writing O is your node. So if O is your node, I am taking this side, that PO, that is L length string, the frequency is F. So this side P is a node, O also node. So you can say that the frequency formula n by 2L T by mu root over. This will come, right? And for OQ string, I am writing the form frequency F dash, that will be again M. Here N, here M. 2 into length here 2L. Into T by mu is 4 mu here, root over. Clear? Now option A, if you read, for node O we have written this two frequency. Now they are telling vibration of composite string. If composite string means both are vibrating. So if both are vibrating, that means both has to be vibrate in the same frequency, right? Clear? Both has to vibrate in the same frequency. Maybe individually their frequency will be different. Let's say I can say that for F1 here it will be 1 by 2L T by mu. It can vibrate with this frequency, but for 2L length string you have to find out where this frequency is falling. So you can say that this frequency will fall here. If I write F dash 4, M equal to 4 if I put here, so this will be coming as your 1 by 2L T by mu. So here they are matching. Got it or not? So this will be your first overtone, here it will be fourth overtone, right? But ultimately it will has to vibrate with the same frequency. Clear? So with node, the minimum frequency of vibration of composite string is mu naught. So they have given this one is your mu naught, right? Now here, if you see, if I want to write down f1 dash, sorry, f1 dash, f2 dash, f3 dash, so every frequency, that is m equal to 1, m equal to 2, m equal to 3, you will find out that this should be less than this f1 frequency. Got it or not? If this frequency is less than f1 for m equal to 1, 2, 3, that means with m equal to 1, 2, 3, this L length string cannot be vibrate, right? So minimum frequency will be then mu naught, right? Because below f4 dash, that is your f dash 3, f dash 2, f dash 1, this string cannot be vibrate. Only this string can vibrate. Clear? But they are telling the composite string, both are L length and 2L length, both are vibrating with mu naught, right? They are telling. So to do this one, this should be the minimum frequency. Clear? Mu naught should be the minimum frequency. So option A is correct. Clear? Now B is telling antinode. Let's say node question first we will solve, then go for the antinode. When the composite string vibrates at the minimum frequency with a node at O, it has 6 nodes including end nodes. So you see here. So what we can say here, if you see, here 4, here it is 1, right? So what will be the standing waveform? It will form like this. Right, it will form like this. Clear? So its spacing is little bit different. So it should be same space, right? It will be look like this. Clear? So you count now how many? So this will be 1, 2, 3, 4, 5, 6. So 6 nodes. Clear? This should be 6 nodes are there. So this will be option number C is correct. You are getting 6 nodes, right? Including the end nodes. 1, 2, 3, 4, 5, 6. Clear? This will be formed like this. Now D option, if you see, no vibrational mode with an antinode O is possible for the composite string. So antinode now. Let's talk about antinode now. So for O is antinode, again I am writing for left side F is equal to 2n plus 1 divided by 4l t by mu root over, and F dash is basically 2m plus 1 divided by 4 into length will be here 2l and t by 4 mu root over, right? This is for that side and this F for P to O string, right? For antinode at O. Now if you see that they are telling in option number B, the minimum frequency of vibration of composite string is 2 mu naught. So mu naught is 1 by 2L T by mu, right? Right? Mu naught is here 1 by 2L into T by mu. This cannot be possible because 2n plus 1 will always give you a odd number, right? So here if you put n equal to 1, it will give you n equal to 1. If you put, this will give 3 by 4l. n equal to 0, if you will put, it will give 1 by 4l. Got it or not? So it will be 1 by 4l. And if you put here n equal to 2, this will be 5 by 4l. So 2 mu naught is not possible to make from this arrangement, right? Make from this frequency basically. And that thing also you note, whenever you find out the antinode, you always tell that there will be odd numbers are coming, right? Clear? So this option cannot be possible, right? Now see, no vibrational mode with an antinode O is possible for the composite string. So for the composite string vibration, this frequency should be matched with this frequency, right? So let's check when they are getting matching. So F by F dash should be 1 then, right? If they are vibrating in composite. Here also this is happen na, F1 and F4, if you divide, this will give you 1. So if you find out here, so F will be 2n plus 1. If you see here, this will be 2n plus 1. Clear? Divided by 4L, T by mu cancel out. This is 4L, this will be 4 will come. So I can write this will be divided by 2m plus 1 into 4 equal to 1. So if you calculate here, this will be 8n minus 2m is equal to minus 3, right? Clear, right? My 4 2m plus 1, yeah, this will be minus 3. So I can write 2m minus 8n equal to 3. This equation has to satisfy. But you see, you put anything into m, 1 2 3 4 5, it is multiplied with 2, that means it's a even number. You put anything to n, 1 2 3 4 5, it is multiplied to 8, it is also even. So even subtracted by even, it give a even number, but here it is odd number you are getting. So it is also not possible, right? So no vibration is possible. Sorry, no vibration is possible. They are telling this is true, yes. So no vibration is possible means this is true. That's what it is saying, right? No vibration is possible, and D also true. So you can say that A, C, D are true. A, C, D are true, right? Now go for this question. So basically here the object at this point, and after reflection and refraction the image will be forming here. That's what they are telling in the question, right? The image also forming here. That means there is two types of lens here, right? There is a plano-convex and plano-concave. If the object is forming, sorry, the image is forming at the object, that means it is sitting at the center of curvature, right? And that center of curvature here for this composite lenses, or you can say that net center of curvature, you have to find out for these two lenses. So you can find out easily. So what you will tell here that for, let's say, find out for plano-convex first. For plano-convex, F1 I am writing, that will be, you know, that R divided by mu minus 1. So R they have given here 9 centimeter, right? So R they have given 9 centimeter divided by mu minus 1. Mu is basically your refractive index, and they have given 1.60 here. So this will be 1.60 minus 1. So this will be 9 divided by 0.6, that is 690, right? So this will be 15 centimeter. So F1 for the plano convex will be 15 centimeter. For F2, that is for plano concave. So plano concave they have not given the liquid refractive index. They have given the n is the liquid refractive index, right? So radius of curvature obviously is same 9 centimeter divided by n minus 1. This will be your F2. But if you see here, this for plano concave, the F2 should be negative, right? This is positive and this should be negative. By formula you know this thing. So now I have to find out the composite center of curvature. To find out, first find out the net focal length or composite focal length. To net focal length, you know that F net I am writing for both the lenses. This will be equal to 2 divided by F1 plus 2 divided by F2. So what will be 2 divided by F1? F1 is how much? 15, right? Plus 2 divided by F2. F2 will be how much? I am writing 9, and this will be 1 minus n. Clear? This much will come. So this will be 45 and this will be 3 6 plus this will be 5 10, right? So 10 minus 10n, right? This will come. So this will be 16 minus 10n divided by 45. So F net you will get how much? F net is equal to your 45 divided by 16 minus 10n. This is your F net. Now for net center of curvature will be 2 into F net. So you can say that net center of curvature and this distance they have given height h. So height h equal to net center of curvature, that is equal to 2 into F net, that will be 90 divided by 16 minus 10n, right? So now this formula you got. Now you have to put the n value and check the h value. First option we are checking, option number A. So option number A is telling that n equal to 1.42. So 90 divided by 16 minus n equal to 1.42 means 14.2. 14.2, this will be 90 divided by 1.8, right? So it is 1.8 means this will be coming as 50 centimeter. So check option number A. So this is correct. Now go for option number B. This will be 90 divided by 16 minus 10 into 1.35, that is 13.5. So this will be 90 divided by 16 minus 13.5 will be your 2.5, right? So this will be 900 divided by 25, this will be coming as 36. So 9 into 100, so 25, 100 cancel out, so it will be 4, 9 into 4 will be 36 centimeter. So this will be 36 centimeter, right? So B will be correct also. Now check for C. Here I am checking for C. For C, n equal to 1.45, h equal to 65, n equal to, so you can say that F3, sorry, not F3, na? So this will be, I want to find out from this formula, right? H equal to 90 divided by 16 minus 10 into 1.45, so 14.5. So 14.5 means it will be your 1.5. So 900 divided by 15. So this is coming 60 centimeter, right? And 65 they have given, so it's not correct. Now D. For D, if you calculate, this will be 90 divided by 16 minus 1.48, that is 14.8. So 90 divided by, this will be your 1.2. So 900 divided by 12, so it will be 90 into 10 divided by 12, so it will be so 7 6 5, right? So it will be 7.5. So this will be coming as 75 centimeter. Clear? This will coming as 75 centimeter. They have given 85. So D also incorrect. So A and B are correct here. So A option and B both are correct, right? Now go to this question 8 number. The specific heat capacity of a substance is temperature dependent and is given by, so specific heat they have given that it depending on the temperature. Heat required to rise the temperature. So for 1 kg they have given, so you will tell that Q equal to ms dt integration. They have given C here, I am writing S. This is C, right? So this will be m equal to 1 kg, you take it out 1 kg. This will be C into T dt. Obviously you have to integrate from T initial to T final, and they have given the temperature in the degree Celsius, so you have to convert into Kelvin. So 73 degree will be 200 degree Celsius, sorry 200 Kelvin, and 27 degree will be your 300 Kelvin. So it will be 200 Kelvin to 300 Kelvin. So see here, this will be C you can take out, and this will be T square by 2 and this will be 200 to 300 c by 2. This will be 300 square minus 200 square. So this will be 10 to the power 4 c divided by 2. This will be 9 minus 4. So 5, right? So 10 into 10 to the power 3 into 5 by 2. So this will get answer of 5. This will be 25, 0, right? So n is basically, they have given 25, n, they are finding out nk, right? So they are finding out the n value. Oh, they have given c equal to kt, na? Sorry, c equal to kt. This is c, we have taken c equal to kt. This is k by 2. This is k, not c. Here also this is k, here also k. Now it is 2500. So the answer will be 25000, 25,000. Clear? This way you can find out. Now a disc of mass m and radius r is free to rotate about a vertical axis shown in the figure. A battery operated motor of negligible mass is fixed to the disc at a point on its circumference. So this is the bigger disc and smaller disc, this one. So I can draw here. So what basically happening, this is your one bigger disc, right? This one is your bigger disc, right? And on this surface there is a motor is connected here, right? And on this motor they are telling that there is another disc is rotating. This motor is connected to this disc and this disc has mass m, radius is r by 2. Here mass m and radius is r. Clear? Now they are telling that the motor is switched on so that the smaller disc rotate with uniform angular velocity omega. So this is rotate with uniform angular velocity. Let's say it is rotating like this with uniform angular velocity omega. So I am rotating like this, upward. So it is rotating like this. Clear? Now if the angular speed which the large disc is rotate omega by n. So if you see here, if this one will rotate like this, along this direction it will rotate. To conserve the angular momentum, obviously this disc will be rotating like this, opposite direction, right? If it is rotating like this, you can say, if it is rotating like this anti-clockwise, this should be rotate clockwise, right? It should be rotated like this. So I am taking this one that it is rotating like this. So it should be rotating like this, right? So it should be rotating like this. And it is rotating omega by n. Clear? And one more thing is here, that if it will rotate, first of all it is rotating, then due to this one it also rotate. Then you will see that this smaller disc is doing two type of motion. First one, it is rotating about its own axis and it is rotating with the bigger disc also. So you have to write down the angular momentum conservation, right? So about this axis I can write, or this O axis I am writing. O axis you can find out the angular momentum conservation. So basically L initial will be how much? 0. So L final has to be 0. Clear? So you have to write down the L final now. So L final I am taking along this direction is positive and downward I am taking negative, right? So you can see here this is rotating like this, so it will be upward. So what will be the angular momentum of this bigger disc? Let's say first write down. So bigger disc is rotating like this, so it will be downward. So you can say that I can write this will be minus m r square divided by 2 into omega by n. Clear? It is down, right? Now I have to write down the angular momentum of this smaller disc. But smaller disc doing it two types of motion. One is rotating about one axis and moving with the bigger disc. So for this type of motion we know how to write down the angular momentum, right? So that angular momentum is written as basically m r cross Vc plus your I omega, right? About which axis you want to find out. Clear? So here if I write the angular momentum of this smaller disc, this is the angular momentum of the smaller disc. So I can write plus, this is rotating like this upward, right? So you can say that this will be half into m r by 2 whole square into omega. This will be like this upward. That's why I am taking positive. Now for this one, for this term, if I write, for this term if I want to write, this will be obviously, if it is rotating like this, bigger disc, so it will take also along this direction. This is your Vc, right? It will be move along this direction. And R will be from here, R will be from here. And this distance obviously R from here to here. So R cross BC, it is also downward, right? You see here R and BC is into the plane. So R cross BC again downward. So you have to write down again minus sign. And it is how much? Mass into R. R is your capital R, right? Clear? And VC you can write here. VC will be obviously omega by n into R. So it will be omega by n into R. This will be your VC. Clear? Because it's rotating, right? So with this center from here to R distance, and this will be VC, and it is rotating omega by n. So VC will be omega by n into R. This much will come. So you can calculate now, and this will be 0 here, and you see here, so omega by n, this will be omega by n. So you take both are one side. So this will coming as m r square omega divided by 8 is equal to, this is omega n divided by n common, m r square common. So half plus 1, this will be 3/2. This much will come. Clear? So I can do the calculation here. So this will be 3 and this you can find out. So m r square omega, I cancel out both side, m r square omega, right? So this will be n equal to 3/2 into 8. So this will be 4, this is coming as 12. Clear? So this question is a good question, I would say, but the language is very big, so it's better to, if you are practiced enough, you can do this one. Otherwise it's not so straightforward, right? Because here you have to write down the general motion formula for the angular momentum, right? If you remember in the rotational motion, or you can say that when we talk about the if you remember this type of problem, so this is your some disk and you put somewhere impulse here in the mid, in the down, and you find out the final velocity. So same type of one, this type of problem came in your this IIT Kanpur, that model question paper, right? JEE Advanced this time. So there also we have to apply this type of formula to find out the angular momentum conservation, right? So this thing you have to remember, and you have to, if this is doing a general motion, then you have to apply this angular momentum formula, right? So basically this is your m r cross Vc, and this will be I omega, that is rotating about its own axis. That momentum inertia you have to find out, and that omega you can find out, right? It is rotating with omega here. Clear? In that way you can find out this one, and the answer is 12 here, right? Answer will be 12. Now 10th number question. So a point source S emits unpolarized light uniformly all direction at 2 points A and B. So this is your S, this is your unpolarized light, and let's say this is your point A, and somewhere here it is B. So intensity IA divided by IB is coming as 2. Clear? If a set two polarities having 45 degree angle between their path axis placed just before point B, then the new value of R. You have to, it's very easy, right? So you will say that there is one polarity you put and there is one polarity you put. Two polarity you are putting, and here if the path axis along this direction, here it will be 45 degree to this one, this is 45 degree, this thing they are telling. So this is unpolarized light, first polarizer. The intensity here will be how much? The intensity will be I naught by 2. The intensity will be here I naught by 2, or you can write IB by 2 because it's IB initially na, so you can write IB by 2. Here it will be again, this will be going this side, so this side it will be IB by 2 into cos square 45 degree because it's 45 degree here, so IB divided by 4. Clear? IB divided by 4, and this I am telling that IB dash. Let's see. New frequency relation IA by IB dash is equal to how much? IA divided by IB by 4. So this will be 4 coming, right? 4 into IA divided by IB. So IA by IB is 2. This will be 4 into 2 will be your 8. So answer will be 8, right? So answer will be your 8. New R will be your 8. Previously it will be 2, now it will be 8. Clear? Okay. Now go to the next question. This is very elementary question, right? You can just formula use and you will get. No, you have to think, nothing you have to do, just formula if you know, you can calculate easily. So you can remember the formula like this. If this is a source and this is your observer, both are moving in same direction, you will say that observed frequency is equal to original frequency, that is source frequency, C, that is the speed of the sound, sorry, speed of the air, right? This will be speed of the air. C minus your velocity of observer divided by C minus velocity of the source. So if you remember, if both are moving same direction, this is the formula. If anyone is changing its direction, you just change the direction, change the sign here. So what I am telling, for case 1 I am taking, for case 1 if I take, for first case, source is moving along this direction, observer is opposite direction, change the sign of observer. So F equal to Fs C plus V divided by C minus V. The source is not changing its direction, and there for first case they have given the observed frequency as well as the source frequency. Source frequency 240, right? Source 240 and observed is they have given 288. This is 240, 288. So you can say that now this is 288 is equal to 240 into observer is changing its direction, so this will be C plus V divided by C minus V. Now for case 2, this will be not known to me, there you have to find out n equal to, this will be 240. Now here see, source is changing its direction, observer is not changing, right? So this will be C minus B divided by C plus B. Source you have to change minus to plus, that thing I have written. So this will be 240 C minus B by C plus B, C minus B by C plus B. If you find out here, this will be coming as 240 by 288. This will be 240 by 288. Clear? So this will be 24 into 24 into 100 divided by 288. So this will get cancelled out. This will be 1, this will be 2, this will be 2, this will be 200 hertz. Right? So it will be coming as 200 hertz. Clear? Now go to the next question. Two large identical water tank, 1, 2 kept on a top of a building of height h are filled with water up to height h each tank. Both tank contains an identical hole of small radius on their sides close to their bottom. A pipe of the same internal radius as that of the hole is connected to the tank 2, and that pipe ends at the ground level. When water flow out of the tank 1 and 2 through the hole, the time taken to empty the tank T1 and T2. Okay, so this thing you remember that result, right? So if I say this is a building or the whatever height h, this is height h, right? Here is one water tank is there, and there is some hole is there, the water is coming out, and here the height of water is small h. Another building or in the same building, or you can say that same height building I am taking, on top of that there is another tank is there, and the water is coming out here, same height water is there, and but now you connected a pipe to the ground here which is h height. This you connected like this, then the water is coming like this here, right? Clear? So it is not looking same for both. Yeah, you can say that this is same height, right? Same height. This is the case they have given. This is first case, this is second case. How much time it will take to empty the tank? Here how much time? So this is I am taking for case 1, this is for case 2. Case 1 result use everyone remember, right? T1 you can find out easily, or T2 also you can find out easily. So I am solving here. So you will tell that, so what will be the velocity of efflux here? You will tell that let's at any time the height of the water is y, right? If the height of water is y, so V1 I can say that is coming out for case 1, that will be 2g y root over, right? And you can apply the equation of continuity. Let's say this area is A, container area is A, and this opening area is very small a, right? So you can say that A into minus dy by dt, minus y because it's decreasing, right? With time this y is decreasing because y is measured from the top and it is decreasing with time. At last it will be 0 because all water will go out, right? Is equal to small a into 2gy root over. So you can say that this will be dy divided by y root over integration is equal to a by capital A with a negative sign 2g root over into dt integration 0 to t, right? So initially the height of the water is h, small h, finally it is 0, right? So how much time it will take? So it will be integration, this will be 2h root over, it will come. So I can do here 2y root over, it will come, and this will be h to 0, this will be minus a by a, and this will be root 2 g, and this will be time t, and this time is t1 basically, right? You can say that t1 time it is taking, they have given. So t1 you can find out, that is a by a minus sign here, and this will be here 0 minus h root over, right? So minus minus get cancel out here, so minus minus get cancel out, and this will be 2g will come this side, so it will be 2 together, this will be coming as 2h by g root over. If you calculate, this will take this side, and here it will be a by a, right? A by a it will come, right? Now similarly T2 you can find out, but here one thing you see, here the velocity of efflux will be at this point, the velocity of efflux obviously you can say that V2 is equal to, at any time I am writing, this will be your 2gy plus h, right? Why? Because it is, this height of water level is there, but here the height also h, right? So this will be your V2. So I can say that V2 is equal to 2gy plus h. Y is the height of the water level at any time t. So here again I can write A into, or I can write capital A into dy by dt with a negative sign is equal to small a into 2gy plus h. This way. So again this will be, you will tell that minus a by a and dy by h plus y root over integration is equal to 2g root over dt integration, that will be 0 to t2 time, and here y is varying again h to 0. So this will be minus a by a into, this will be 2h plus y root over, right, and it will h to 0 is equal to 2g root over, and this will be t2. So t2 if you find out, I am writing directly, because one time you put 0, this will be h minus h plus h, and there is one minus sign is sitting here. So this will be obviously 2 into initially minus, if I take, this will be h plus h root over minus h root over divided by your 2g root over and a by a, right. So this will be t2 equal to how much you are getting. So it will be 2h plus h root over minus h root over root 2, right, root 2 divided by g root over a by a. Clear? This much you will get. T1 and T2 you got. Here I am doing the rest part, you can say that. So here I am doing T1 by T2. So they have given T1 by T2, right, and they have given h equal to 16 by 9. So T1 divided by T2, if I find out, T1 equal to 2h by g, a by a. So a by a get cancel out, and g root over also cancel out, and root 2 also cancel out, right. So this will be only h root over divided by h plus h root over minus h root over. This will come, right. So you can take this h to the denominator. So this will be 1 divided by h by h plus 1 root over minus h by h root over. This is 1 by h by h, you see 16 by 9. So this will be 16 by 9 plus 1 root over minus, this will be 16 by 9 root over. So this will be 9 25 by 9, this will be 1 by 25 by 9 will be 5 by 3 plus minus is there, na, 25 by 3 minus, and 16 by 9 this will be 4 by 3. So 4 minus 4 by 5 by 3 minus 4 by 3, 1 by 3. So this will be 3. Clear? So the answer will be 3 here. Okay. So like that you can find out. Obviously this answer you remember, right? This is remember. Only this thing you have to calculate and you can find out, right? Okay. So this question we have solved. Then the answer is 3 is coming. Next, go to the next question. So a thin uniform rod of length L and certain mass is kept on a frictionless horizontal table with a massless string of length L fixed to one end. So they have given this one. So this is your string length L and this is your rod, that is again length L, right? Now the other end of the string pivoted to point O. If a horizontal impulse P, so you are giving a impulse P here, this is the impulse you are imparting here, this is the impulse you are imparting here, this is the P here, and this distance is basically your x they have given here, and x they are telling that L by N, right? Then the rod and the string revolve together around that point O. So it will be revolving around circular path, you can say, around point O, with the rod remaining aligned with the string. In such case the value of N. So they are asking what will be the value of this X. From there you can find out N easily. So what you have to do that, first of all I am drawing here what it is basically. So this is a rod of length L, and from here there is a string is connected. So this length is L, again this length is L, right? And this is the midpoint here. This will be L by 2, and here the impulse they are putting, and from mid to this distance is your x. They want to find out this x basically. Then you can find out the n value easily, right? You have to find out the value of x. So impulse you are putting p. So obviously you can say that apply impulse momentum theorem, right? So you apply impulse momentum theorem. So impulse momentum theorem is saying that p equal to change in momentum. Change in momentum, initial momentum will be 0 and final momentum will be m into vc. M into vc, because this center of mass is moving along this direction with vc, right? M into vc. If it is rotating with, because it is revolving, let's say it is rotating with omega, then you can find out the vc value, right? So obviously the vc will be, just a minute. Obviously the vc will be L plus L by 2 into omega. Clear? Vc will be L plus L by 2 into omega. So this will be 3L by 2 into omega. So you can find out now m into Vc will be 3L by 2 into omega. This will be your this will be your impulse, right? P. Now one more thing you can apply, that is angular impulse, right? So for angular impulse, if you put angular impulse will be, this is your first thing you got. Angular impulse if you want to write, so you will say that P into this distance, right? L plus L by 2 plus x. So L plus L by 2 plus x is equal to initial angular momentum you have to find out, and final angular momentum you have to find out. So final angular momentum, obviously you will tell that about this axis, this point O point, whatever axis is going this direction, angular momentum about this axis will be your if it is rotating with omega, so we will tell that this will be your m L square divided by 12, m L square divided by 12 plus this distance, right? M into L by 2 plus L whole square. This full into omega, right? So what I can do, just a minute, this equal to basically you can say here m L square divided by 12 plus m into this distance from this O to this center, that is L by 2 plus L whole square, right? And this into omega. This will be your final angular momentum about this point. Initial angular momentum will be your 0, right? So you write down the angular impulse about this point, and that is equal to L final minus L initial. This is your L final, L initial will be 0. Now see here, so P value you can put here, right? This will be one equation and this will be another equation, and from these two you have to calculate all these things. So what you will tell, so P value is m into 3L by 2 into omega. Here it will be 3L by 2 plus x is equal to, this is m L square by 12 plus this is equal to m into 3L by 2, right? 9L square divided by 4 into omega. This much will come. Clear? So see here which is getting cancelled out, omega is cancelling out here, omega get cancelled out, and you can say that mass also get cancelled out, here mass get cancelled out, 1L also get cancelled out. Okay, so now you get 3 by 2 into 3L by 2 plus x is equal to L by 12 plus 9L by 4. Okay, so this is coming basically 12 L plus this will be 3, this will be 27 L, that is 28 L by 12. So I can say that 3 L by 2 plus x is equal to 28 L divided by 12 into 2 by 3. So this will be 618. So 28 L divided by 18. This much will come. Now you can find out the x value. X will be 28 L divided by 18 minus 3 L by 2. That will be 18. 28 minus this will be 27 into L. So this will be coming L by 18. So x equal to you are getting L by 18. And x value they have given L by n, right? X value they have given L by n. So this is basically your L by n. So which implies that n equal to you get 18, right? L equal to 18. So the answer here will be, you can say that L equal to 18. Clear? This one you can solve, right? First thing you have to apply the impulse momentum theorem, then angular impulse you can apply and you will get the answer, right? So whenever impulse is there and rotation is there, we do like this basically. Clear? Go to the next question. Okay, 1 mole of a monoatomic ideal gas undergoes a cyclic process JKLMJ. Okay, here it is going cyclic process. Okay, so this is a cyclic process and PT given, P y axis and T along x axis. So now we have to match list 1 and list 2. See here, in list 1 0 is present, right? So if 0 is present, we can check whatever 0 can be possible here. Work done in complete cyclic process, 0 cannot possible. Change in internal energy of the gas in this process, Jk. So Jk internal energy, if you find out, you can find out easily, right? Because monoatomic gas 1 mole for Jk. So Q option if you check, for Q option if you check here, for Q option if you check, this will be change in internal energy J to K. J to K change in delta U basically F by 2 NR delta T. So this will be F will be 3 by 2, N is 1, this will be R, delta T will be 3 T naught minus T naught, that will be 2 T naught, or I can write here 3 T naught minus 2 T. This will be 3 T naught minus T naught, this will be 2 T naught, then 2 get cancel out, this will be 3 R T naught will come. Which option it is matching? 3. So Q is basically 3. Check which one it is matching. Q3 here, Q3. So C option cannot be possible, D option cannot be possible. Only A and B, in between A and B is possible because Q is 3 there. Now check which one I can do so that it will be easy to find. P is 1, P is 4, Q is 3, Q is 3, that thing we got, R5, R5. So S for 2, right? So P is, you have to find out everything, right? Work done means every process you have to find out. Let's find out S. Change in the internal energy of the gas in the process of Mj. So Mj if you see, that thing I am telling you about, right? 0, because it's an isothermal process, right? Mj is an isothermal process. So for internal energy will be 0. So for S, internal energy will be 0, that is 2. So S equal to 2. Which one it will be? S equal to, so A cancel out, so B will be your correct. So like that you can do this one in 2 minutes, right? Or 1 minute, less than 1 minute it will take to find out, right? Correct? And you can find out all other option, right? For P you can find out, for each process you can write down work done and you can find out. For R also, that is heat given to the gas in this process KL. For heat given to the process in KL means what? In KL process is a isothermal process. So internal energy, change in internal energy is 0. So whatever heat is given, that is the work done, right? So you can find out the work done and that work done is basically equal to the heat is given. Clear? Obviously you can find out, because isothermal process you can find out the work done here. Okay, so B option will be your correct option. Next, go to the next question, that is 15. So for identical thin square plate, so these are capacitor. Many times we did this type of problem. S1, S2, S3 and S4, each side A are kept parallel to each other with equal distance. D is less than A. So this distance is A basically. This is A, and this distance also A, because this is square plate, right? Now we have to find out all the relation. So first see the capacitance between S1 and S4 with S2 and S3 not connected. The capacitance between S1 and S4 with S2 and S3 not connected. So basically what is happening here, for P thing I am thinking, so this is one plate, this is one plate, this is one plate, this is one plate. So this is 1, 2, 3, 4, S1, S2, S3, S4. S1 and S4, so connect it to a battery. You know how to find out the equivalent. So if you connect to a battery with S2, S3 not connected, so S2, S3 not connected. So here one capacitor C0, this is C0, this is C0. All three are in series, right? All three are in series. So equivalent will be C0 by 3, right? Obviously this will be C0 divided by 3. So which option it is matching? So it will be P is your 3. Check which one it is matching. P 3, 3, 3. Yeah. B option will be eliminated. So A, C, D. In between A, C, D, there is one option is correct. Now this will be 3, 3, 3. This will be 2, 2, 2. So I should not check Q, because there is 2, 2, 2 is there. For R it is 4, 4, 2. 4, 4, 2. And S equal to 5, 1, 5, right? So 5, 1, 5. Let's check this S we can find out. If it is not in S, if it is matched, then we can find out the R also, because Q is if you find Q, everything is 2, right? You unnecessarily do this calculation, right? So let's find out for S. For S, the capacitance between S1 and S2 with S3 sorted to S1 and S2 sorted to S4, right? So this is 1, 2, 3, 4. Between S1 and S2, this is connected here. Now they are telling S3 sorted to S1, this one sorted to this one, like this. This type of arrangement, you know how to do this thing, right? So here I am doing. This is basically 1, 2, 3, 4, and this point I can take A, this point I can take. Let's draw it little bit bigger. So this will be 1, 2, 3, 4. So you have to find out between A and B, sorry, 1 and 2. This is 1, 2, 3, 4. And they are telling that 1 and 3 are connected, 2 and 4 are connected. This is the case. Let's choose this point is A and this point is B. Here you take a point A, here you take a point B. From A, 1 and 2 there is a capacitance. So 1 and 2, that is, let's say take this is your 1 and this is your 2, this is connected like this. Clear? Now 2 and 3. So 3 is connected to A and 2 is connected to B. So 2 and 3. So this will be 3 and this will be your 2, another capacitor. And then 3 and 4. If you 3 and 4, 3 is connected to A, 4 is connected to B. 3 is connected to A. So again 3 is connected to A, 4 is connected to this. So this will be 3, 4. Now you can find out the equivalent capacitance here easily. Clear? So this will be C0, this will be C0, this will be C0. All are in parallel. So equivalent will be 3 C0. So S is 3 C0. You are seeing S, right? So S will be your 3 C0. So 3 C0 is which one? 1. S is matching with 1. Now check which one is. Oh, 5, 5 is not matching, na? So this will move away, this will also move away. So this will be correct. So C will be your correct, right? Or if you calculate r, then what will happen? This 4 and 4 get match, right? Okay, so okay, anyway you have to find out, right? If you calculate s, then you can easily get, and all other option you can check easily, right? Now go to the next question. So a light ray is incident on a surface of a sphere of refractive index n at an angle of incident theta naught. So this is the sphere and the light is falling on it, incident on it. The ray partially reflect into the sphere and angle is reflection phi naught. It's the same question, you did it many times. And then partially reflects from the back to surface. The reflected ray emerges out of the sphere after a partial reflection. The total angle of deviation of the emergent ray with respect to the incident ray is alpha. Match the question. Okay. So I am drawing here this one. So this is your basically a sphere, you can say, and you can say that this is your center here. Let's say the light ray is falling like this, right? And you know that normal to the your sphere is basically perpendicular to, and it is passing through the center, and this angle they have given that theta naught, angle of incident, and this is basically normal, you know. Now the ray is traveling, obviously the ray will slightly deviate towards the normal and it will, let's say, move like this, right? If it is moving like this, again it will be partially reflect, clear? It will be partially reflect, and this angle they have given phi naught, right? This angle phi naught, and you will tell that there is a normal to it at this point. This is the normal, and the ray is now traveling along this direction. So it will be, now it will be again following this path. Now again it will be, there will be a normal, passes through the center, and now it will move along this direction, slightly deviate and go like this, clear? So now write down the angle. This is phi naught, this is r, this is r, this also phi naught, clear? If this is phi naught, this has to be phi naught, clear? This has to be phi naught, and if this is phi naught, this also have to be phi naught, and this is your theta naught, clear? This thing you got. Now you have to find out the deviation here. So deviation, obviously you will tell that if it is moving, instead of bending, if it would go like this, how much deviated. So it is deviating here, let's say I am writing delta 1, deviation will be how much? Theta naught minus phi naught, theta naught minus phi naught, right? And here if it will go like this along this direction, and it will be deviated this much, and this deviation obviously pi minus 2 phi naught, that is your delta 2. And here also if it will move like this, so there is a deviation that will be theta naught minus phi naught, right? This will be theta naught full, this will be phi naught, so theta naught minus phi naught will be your deviation, right? So delta 3 I can write here theta naught minus phi naught. So net deviation will be how much? So everything I have taken in clockwise direction, right? If you see, it is clockwise, it is also clockwise, everywhere it is clockwise. So net deviation they have given alpha equal to delta 1 plus delta 2 plus delta 3. So it will be theta naught minus phi naught plus pi minus 2 phi naught. This will be theta naught minus phi naught, theta naught minus phi naught. So this will be theta naught 2 theta naught. This will be plus pi minus 4 phi naught. This relation we got alpha equal to, I can write pi plus 2 theta naught minus 4 phi naught. This much I will get. Okay, now I have to check all the answer. So what I got, I am writing here. So alpha I got pi plus 2 theta naught minus 4 phi naught. Now for P option, n equal to 2, alpha equal to 180 degrees. So n equal to 2 means, if n equal to 2, here you can say that sine of theta naught equal to 2 into sine of phi naught, right? Here theta naught, here it is phi naught. So you apply this Snell's law, you can write down this one. So I can write here sine of theta naught is equal to, for P option I am checking, 2 into sine of phi naught. So alpha is 180 degree. So if alpha equal to your, this is your alpha. So if alpha equal to 180 degree, then your 2 theta naught equal to 4 phi naught. So theta naught equal to 2 phi naught you will get. So this thing you can write sine of theta naught is equal to 2 sine of theta naught by 2. Clear? This is, you can write sine theta naught is 2 sine of theta naught by 2 cos of theta naught by 2 is equal to 2 sine of theta naught by 2. So sine theta naught by 2 cancel out, 2 get cancel out. Clear? And cos of theta naught by 2 you got as 1. So theta naught by 2 is equal to your 0. So theta naught will be obviously 0. So this will be 0. Which one it is matching? If you see here, so option number 5 only 0 is there, right? So P is 5. So C and D will be going cancel out. C and D is obviously eliminated here. So A and B is there. So A and B 5 they have given. So P is 5 basically, and Q21, R12, S44. So let's find out Q, then it will be clear, right? In between 2. For Q, n equal to root 3. So if n equal to root 3, so sine of theta naught equal to root 3 sine of phi naught. If alpha equal to 180, again the same condition, it will be theta naught equal to 2 phi naught. This is the same condition, right? The possible value of theta naught, here you can say that again, you can write this will be 2 of sine of theta naught by 2 cos of theta naught by 2 is equal to root 3 into sine of theta naught by 2. So sine of theta naught by 2, sine of theta naught by 2 cancel out, cos of theta naught by 2 is equal to root 3 by 2. So theta naught by 2, basically root 3 by 2 means you can say that this will be 30 degree, right? So 30 degree is pi by 6. So theta naught is coming as pi by 3, that will be 60 degree. That is coming as 60 degree. Clear? So theta naught equal to 60 degree, which one it is? For Q 60 degree. So option number 2 is there, right? So option number 2 is there. So you can say that this is Q is matching with 2. So Q is matching with 2, and they have given also 0 degree. So obviously 0 degree is for theta naught, 0 degree means what? Normal incident, right? So there will be 180 degree deviation obviously there, and it will be falling normally on the surface, right? So that condition, if I say how it will look like, it will be, let's say this is your center, and it is basically for theta naught 0 means what? It is falling like this and reflecting like this. Same way it is falling, same way. So deviation obviously 180 degree anti-parallel, right? Clear? So Q is your 2. Q is your 2. 0 degree also possible. If you put 0 degree here, so phi naught, theta naught, if you put 0 degree, then obviously it will be 0, right? So it will satisfy here, right? Now you can calculate for other option, but this option is enough to find out this relation. P is your 5 and Q is your 2. So option A is correct, B is incorrect. So this you can find out, or you can find out n equal to root 3, phi naught value you can find out the same thing, right? So this is for root 3. If it is theta naught is pi by 3, so phi naught will be obviously your theta naught by 2, right, is pi by 6. So this will be 30 degrees. So you can say for r equal to, this will be 1. So you see here r equal to 1, it is matching also. So option A is correct, right? Okay, this is done. Now this is the last question, and this is you can do in 1 minute, less than 1 minute. In the circuit shown in the figure contains an inductor L and capacitor C0 and R0, ideal battery they have connected. Circuit also contain two key K1, K2 initially, both the key are open. Both the key are initially open, right? There is no charge in the capacitor. At an instant K1 is closed. So K1 you make close. So if you make K1 close, how the circuit will look like? K2 is open means this will be resistance, there will be inductor, and it is closed, and it will be like this. K1 close, first case. Immediately after this, the current in R0 found to be I1. So initially if it is closed, so you know the relation, right? You know that current I equal to E by R 1 minus 0 power minus RT by L. So at t equal to 0, the inductor behave as a open circuit, or you can say that current is 0. So obviously I1 then 0, right? Instant, just after closing the key, the current will be 0, right? Now next thing they are telling, so I1 equal to 0, which one it is matching? P is 1. So P is 1, 3 options. So D will be eliminated. So A, B, C are there. So D will be eliminated. Now next, the value of I2. Can you find out I2? I2 will be the current attains at steady state value I2. So after some time you have to find out I2. Obviously after some time, steady state means what? This t equal to infinite, right? This term will be 0. So it will be E by R only. So E is given 20 volt and R is your 5 ohm. This will be 4 ampere. So this will be 3. So Q is 3. So B option eliminated now. So Q3. So now which one you can see here? What you can do? So if you calculate 1 it is this is 3 is there. R equal to 2. So S is 5 4. So let's calculate S. Let's calculate S. Because S is different, right? We can say that which one it is coming. Right? So let's calculate the S. So S is what it is telling. The value of V0 in the volt. When the V0? So thereafter K2 is closed and simultaneously K1 is opened. Okay, so K2 is closed, K1 is open. Now it will be LC circuit, right? So how it will look like? So here I can say how it will look like. Now here I am doing it. So it will be now K2 is closed. So it will be now capacitor and there is a inductor. And it is K2 is open means what? There will be no source here, right? And the current initially in it is I. That will be 4 ampere, right? And this will be your 10 microfarad and this will be 25 millihenry. This is the case. So you have to, if you want to find out the V0, that is and the voltage across C naught oscillate with the amplitude V naught and the angular frequency omega naught. So if you find out V naught, you will tell that, you know that in LC circuit the energy will oscillate, right? The energy for the capacitor will be half CV square and this will be half Li square. Both are same, right? Energy will oscillate. So here if you find out the V, so V obviously this will be Li square divided by C root over, right? This much will be. So L is how much? 25. 25 into 10 to the power minus 3 into I is 4 square divided by C is 10 into 10 to the power minus 6 full root over, right? So this will be 5 into 4, it will come outside, and this will be 10 minus 5 and this will go up, this will be 10 to the power 5 2. So this will be coming as you can see here, this will be 10 to the power minus 5 and this will go up, this will be 10 to the power 2, right? Because minus 3 will cancel out, so 10 to the power 2, so 10 will come. So this will be 20 into 10, that will be 200 is coming. So V value is 200, right? V value is 200. So S is basically which one? 200 is 5. So S will be your 5. So which one is S is 5? So option A, if you say S is 5, because C is S equal to 4 they have given, and omega naught value easily you can find out, right? Omega naught also you can find out. If I tell that R I want to find out, omega naught will be what? You see here, RT by L, so this will be R by L, omega naught equal to R by L, right? So R will be how much? 5 divided by L is 25 millihenry, right? So this will be 1 by 5 into 10 to the power 3. So this will be 0.2 into 10 to the power 3, right? R is 5, this will be 25, 1 by 5, yeah, this will be 10 to the power, so this will be 200, right? This will be 200. Something mistake we did here. This will be 25 R by L, right? Oh, sorry, omega naught there, not this one, for not RC circuit. They are asking the omega naught for the LC circuit, right? So for LC circuit, you know, sorry, this will be your R value, right? R is, for LC circuit they are asking omega, because they are oscillate, they are telling that omega naught. So omega naught equal to obviously 1 by LC root over. So this will be 1 by L will be your 25 into this will be 10. So this will be 25, I am writing 25 root over, and top I can write this will be 10 to the power minus 5, this will be 10 to the power minus 3, right? 10 to the power 8. So this will be 10 to the power 4 divided by 25, right? So this will be 10 to the power 4 divided by your 2, not 5. So the 25 root over will be 5. So this will be 2 into 10 to the power 3, that will be 2000. 2000 will come, na? Omega naught will be 2000 radian per second. This will be radian per second, 2000 radian per second. So the value of omega into kilo radian, so they have given in kilo radian, so kilo means 2 kilo radian. So this can omega naught equal to, I can say 2 kilo radian. Kilo radian per second. This will be your answer. Clear? So option A will be correct. So this so for matching the list, you have to be little bit smart, and you have to choose which option is not matching, and if which one you should calculate, so that you can avoid unnecessary time loss. Clear? Okay.